Hi there everybody, let's have a look at this GCSE question here. It's quite an advanced algebra question, and I know, having read through it now, that I'm going to be using the quadratic formula, hence the title of the video, but I'm going to have a look at telling you how that we get to that stage. So, a rectangular lawn has a length of 3x meters, and that's given there, and a width of 2x meters, and that's given there, and then it's surrounded by a path of 1 meter on all three sides. So a meter there, a meter there, and a meter there. So we're going to be able to establish some dimensions here in a minute if possibly we need to. It then says the total area of the lawn and the path, so basically the whole rectangle here, is 100 meters squared. Part A, show that 6x squared plus 7x minus 98 equals 0. Now, we're going to have to do a little bit of assumptions here, but what we do know is that we have a quadratic expression here that then turns into an equation, and we know that that's going to come somewhere from the information here, and the key here is that we're talking about the area of the lawn and the path. So we're talking about this entire rectangle. So let's start off by setting up some dimensions for the entire rectangle then, because at the moment we've got the lawn separately from the path. Now the first thing I'm going to do is I'm going to have a look at what this dimension here would have to be given the information that I have provided to me in the diagram. So let's have a look at the height here. Let's transfer some of these dimensions across. I know up to this point that the height is 2x, and then I know the remainder of this height is 1. So I can say the overall height is going to be 2x plus 1. Then the length or the width of the garden, depending on how you want to look at it, is going to go from this point here to this point here. So we're going to be looking all the way along here. And I've got a meter here. Then I've got this length of lawn here, which is equivalent to 3x, and then I've got a meter there. So let's just recap that. A meter and a meter, that's 2 meters, and a 3x, so I've got 3x plus 2 meters. So I now have the dimensions of the entire garden, and I know to find area that I'm going to multiply this by this. So let's do part A here then. I'm going to multiply 3x plus 2, and I'm going to put that all in brackets because otherwise we might confuse ourselves and separate the two terms later on. I'm going to multiply it by 2x plus 1. So what I in essence have here is expanding a quadratic, and there's a video on that to watch if you're not sure how to do this, so I'm going to rattle through this quickly. So I'm going to have 3x multiplied by 2x, which is 6x squared. And this looks like it's beginning to form our question nicely now. I'm going to have 3x multiplied by positive 1, which is plus 3x. I'm going to have positive 2 multiplied by 2x, which is plus 4x. And I'm going to have positive 2 multiplied by positive 1, which is positive 2. I'm going to simplify this because I can put like terms together and they're both x's. So I end up with 6x squared plus 7x plus 2. So what I have here is an expression for the total diagram, and then we're told that the total area of this, and we've just found an expression for that because we've done width times height, is equal to 100 meters squared. So this is equal to 100. So let's think about what we've written there. This is an expression for the area, and this is the area. So they are equal to each other. This is the area, and this is the area, so they are equal. So all that remains for me to do is make this look like this, i.e. I've got to make it equal 0. How am I going to make this equal 0? Well, I need to get rid of this 100. So I'm going to take 100 away, but remember with anything in maths where we've got an equation we have to do the same thing to both sides. So I'm going to take 100 away from this side as well. So I end up with my 6x squared plus 7x. Then I've got 2 take away 100, well, that's going to be minus 98, and that's equal to 100 take away 100, well, that's 0. Have I shown that 6x squared? Yes. Plus 7x? Yes. Minus 98? Yes. Is equal to 0? Yes. So there is my demonstration by using some algebraic terms to find the area of this diagram and make it form into an equation, which I've then just done a little bit of rearranging to. Okay, part B, calculate the area of the lawn. So I have, for my area of my lawn, 6x squared plus 7x minus 98 equals 0. So, thinking back to our classwork, what are we doing here? Well, we're solving a quadratic equation. And there's three ways to do this in your GCSE. The first is by factorising, although we've got some quite large numbers here, but that's possibly doable. The second is by using the formula. And the third is by graphing, although let's be honest, in an exam there'll be a giveaway if they're asking you to solve by graphing, because there'll be some graph paper underneath this question, which isn't here. Now, I've got a choice of factorising or using the quadratic formula, and as there isn't any indication here to suggest which one I'm going to do, I'm going to start by using the formula, because that tends to work more often than not. So the first thing I'm going to do is I'm going to write out the quadratic formula, which, remember, for our GCSE guys, we have to remember it's no longer given in the exam. So, minus b plus or minus, and we'll talk about that in a minute, the square root of b squared minus 4 times a times c, all divided by 2 lots of a. So there's our quadratic formula. Let's remind ourselves of a, b and c. A is the number in front of x squared, b is the number in front of x, and c is the number on the end at its own. So all I'm going to do now is rewrite this, but I'm going to substitute these values in. Now, let's have a look at the formula. The minus already exists there, so I'm going to write the minus out again. My b value is positive 7, so I'm going to write it in as 7. We're separating the number term now, so the x is no longer going to be used. Plus or minus the square root of b squared, we know that's 7, minus 4, and I'm going to write the time signs in here so I don't confuse myself, times a is 6, times c is minus 98. And that's already worrying me a little bit here because I've got a couple of negatives here I'm going to make sure I don't get confused on. All divided by 2 lots of a, which becomes 2 lots of 6. Now it's a simple case of working our way through this, using a little bit of BIDMAS, but working out which bits we can do in order. So let's have a look here. Can I do anything with this minus 7 yet? Well, no, because nothing's being done to it. So I'm going to write the minus 7 back down here for now. I've still got this plus and minus. Can I square root this? Well, no, because I don't have a number in there to square root yet. So I'm just going to write in my square root sign. I can do 7 squared. 7 squared is 49, so I can put that in here now. Now let's have a look what I've got here. I've got minus 4 times 6. Minus 4 times 6 is minus 24. And then I'm going to times that by minus 98. So I end up with 24 times 98, which is 2,352. And this was negative and this was negative, and 2 negatives make a positive. And all of that's divided by 2 lots of 6, which is 12. So it's looking much more simple now, and it looks like we're nearly there. So let's keep going with this. So next stage then. Minus 7, can't do anything with that yet because that's still there by itself. Plus or minus. Now I've got the square root of 49 plus 2,352, which is 2,401, and I'm going to divide that by 12. Okay, so we're nearly there now. Now, that indicates that this is quite a complex number. You probably don't know that off the top of your head, so maybe this would appear on a calculator paper. So I'm going to have minus 7 plus or minus, and now I've got the square root of 2,401, which is 49. And then I'm going to divide that by 12. Okay, here's where this plus and this minus symbol comes in. This basically says do this question twice, because we know from class that a quadratic has 2 solutions, so this is where they come from. So I'm firstly going to do minus 7 plus 49 divided by 2, and then I'm going to do minus 7 minus 49 divided by 2. So I'm going to do those in 2 stages. So let's have a look. We've got minus 7 plus 49, so that's going to be 42. Sorry, that's not 2, is it? Let's have a look back. Don't make a silly mistake there. Divided by 12. And I'm going to divide that by 12, and that's going to give me 3.5. And I'm going to do minus 7 minus 49, which is minus 56, divided by 12, which is going to give me minus 4 and 2/3, or 0.6 recurring. So there's my 2 solutions for x. So we're nearly there. The question now says calculate the area of the lawn. So I've got 2 possible values for x, and I'm going to need to use a little bit of common sense here. So I need to ask myself, which of these could be a value for x? So, could x be negative? Could I have a negative distance in my lawn? Well, no, that's not possible. I can't have a minus distance in my lawn. So I'm going to rule out the fact that it could possibly be minus 4 2/3 as the value of x. So that's going to leave me with the 3.5. Now, my lawn has dimensions of 2x and 3x. So here's my lawn. And this bit's 3x long, and this bit's 2x long, and I've now decided that x is worth 3.5. So my 3.5 is going to go in here, and my 3.5 is going to go in here. So instead of 3x, I've got 3 lots of 3.5, which is 10.5, and I've got 2 lots of 3.5, which is 7. How do we find area? Well, we multiply these dimensions together. So I end up with 10.5 times 7, which would give me 73.5. It was in meters, so meters squared. Calculate the area of the lawn. The area of the lawn is 73.5 meters squared, and I got there by knowing how to solve quadratics by using the quadratic formula.